Okay, here we're looking at the properties of logarithms. So the properties of logarithms, currently so far you know how to go from exponential to logarithmic form, logarithmic back to exponential form, and you should be able to evaluate and simplify basic logarithms. Now, at this point, the properties of logarithms, there are three main properties and a couple of other side notes that I want to take a look at. So, first thing, if I have let's just take a look. We know log base A of B equals X, and we can convert that to A raised to the X power equals B, right? We know exponential, logarithmic, and we can go back and forth between the two. Okay, we know this is the base, right? The base is A. Now, what happens if I take a look at a logarithm that doesn't have a base? So what if there is no base? In other words, let's take a look at something like log of 7. There is no base. What does that mean? Well, what that really is telling us is log base 10 of 7. Okay, so if there is no base, it's understood that it's log base 10. So if you don't see one, then it's understood to be log base 10. It's kind of like saying x is the same thing as x to the first power, or x is the same thing as 1 times x, right? It's not necessarily written there, but it's understood to be there, right? That exponent isn't there, but it's understood that it's a 1. Well, if there is no base, we understand that it's 10. And the reason why we use log base 10 all the time is because we have 10 fingers, and we count in base 10. So base 10, log base 10, this is, if you don't see a base, it's got to be base 10, okay? So know that. Now, we have the three big properties of logs, okay? Our three properties. The property number 1, I call this the addition multiplication property. What it says is if I have the log of something plus the log of something else, then it's equal to the log of those things being multiplied. So here, what I'm saying is log base 10 of A plus log base 10 of B is equal to log base 10 of A plus B. Now, this works as long as the bases are the same. So over here, let's make a little side note to ourselves. Say, so note, it works as long as the bases are the same. This is going to be true for all three of our properties. And here, just to show you that this is true, what I could do is I could say, let's see, we have a log button on our calculator, and it's understood to be log base 10. So log, and let's just, I don't know, log of 5 plus, let's go log of 4, for example. Log of 5 plus the log of 4. It gives us some random number, right? Some weird 1.3, whatever. So the log of 5 plus the log of 4. Now, according to this law, this property, excuse me, log of 5 plus log of 4 should be equal to the log of 5 times 4, which is going to be 20. So we say log of 20. Do we get the same number back out? For sure. Sweet, it works. Okay. The second one is going to be subtraction. All right, addition, multiplication. The next one is going to be subtraction, division. So if I have log A minus log B, then that's going to be equal to the log of A over B. All right. Again, if there's a subtraction sign, we divide. If there's an addition sign between two logs that have the same base, right? Addition sign, then we multiply the arguments. Subtraction sign, we divide the arguments. And we make sure it's in order, right? A over B. And then the third one is our exponential property. If I have the log of A to some power, so let's call it P. So log base 10 of A to some power is equal to P times the log of A. Now this one's a little bit different. So that P, that exponent comes out front. So A to some power, that power comes in front of the log and it's going to get multiplied. So we can take a look at this on a calculator to see. So, you know, like, let's say 2 to the third power is 8, right? So log of 8 is 2 raised to the third power. 8 is 2 raised to the third power, and we get some number, right? So the log of 8 is the same thing as the log of 2 to the third. Well, I should then be able to take that 3 because it's an exponent, right? That 3 then would come out front, and it should be the same thing as 3 times the log of 2, right? So let's go take a look. So if I plug that in, I get 3 times the log of 2. Do I get the same number back? Oh, yeah. That feels good. All right. So anytime you have an exponent, that exponent comes out front. So here we had an exponent of 3. The 3 comes out front, and we no longer have an exponent, right? So the exponent will come out front, and we have no exponents whatsoever. So these are the big 3. Right, what we're going to do is we're going to practice expanding. So if I start here, I can expand it into multiple logarithms. And then after that, we're going to condense. If I start here, I can condense it into one single logarithm. So let's take a look at what some practice problems might look like with that. Roll it over, Smokey. All right, here we go. This one says expand each logarithm. So here I have the log, no base. So this is log base 10. And yeah, okay, log base 10 of 5 times 3. Well, I can split this into 2 logarithms. So I can split this into log base 10 of 5 plus log base 10 of 3. And that's it. That's as far as I can take it. All right, let's take a look at another one. Ooh, now here, I have several things happening. I have 6 over 5, so 6 divided by 5, but I also have this exponent. Now, I need to take a look. The argument is 6 over 5, and all of this, the 6 and the 5, both have that exponent. So the first rule that I have to follow here is the exponential rule. That 6 has to come out front. So I'm going to start by saying 6 times the log of 6 over 5. Now I can split that log into 2 different logs. The log of 6 minus the log of 5, right? Division is subtraction. So it's going to be 6 times the log of 6 minus the log of 5. And then if I wanted to, I could distribute the 6 through, and I'd end up with 6 log 6 minus 6 log 5. So, yeah, when the exponent's on the outside, I want to handle the exponent first. What happens, though, if the exponent is on the inside? So let's take a look at a problem like this one here. Here, I have multiplication happening between my terms. There's no exponent on the outside here, but there's an exponent on the inside with the z. So I need to split these up with addition first, and then I can handle that exponent. So I end up with the log of x plus the log of y plus the log of z squared. And now, finally, I got to take that 2 and bring it in front of just this log. Notice I'm not going to have a 2 in front of these guys because there was no exponent for y or x. So my final answer here is going to be log of x plus log of y plus 2 log of z. Yes, Mr. Stevens, your 2's and z's look similar, but my z has a dash through it, the 2 doesn't. So that will be my final answer. All right, so that's expanding. right? You're taking one logarithm and you're going to expand it into multiple logarithms. Started with one and I split it and expanded into 3. Now what happens if I start with multiple logarithms and condense them into one single logarithm? Glad you asked. Well, I am the one that asked it. Anyways, the directions say condense each expression into a single logarithm. So here I have log, and these are all base 10, log base 10, base 10, base 10. So log of 2 plus log of 11 plus log of 7. Well, I'm going to turn that into the log of 2 times 11 times 7. And 77 times 2, what's that? 154. So I end up with the log of 154. Okay, no big deal. Right? Addition turns into multiplication. So this addition turned into multiplication here. Now, what happens if I have, hang on now. This one's a little bit different. The 3 is not part of the argument. The argument is just the 7. What this is saying is 2 times log of 7 all divided by 3. I could rewrite this as 2/3 times the log of 7. Right? Anytime you have fractions like that, whenever you divide here, it's the same as multiplying by a fraction. So 2 and the 3, I'm going to pull that out front. And once I do that, now I can see I have a multiplier in front of a logarithm. This is that third property where you have a multiplier in front of a logarithm. That then becomes the exponent of the argument. So now my final answer here would be log base 10, right, of 7 raised to the 2/3 power. Now, if you look at your laws of exponents, the 2/3 power, what that really says is the log. Now we have the cube root of 7 squared. And that would be my final answer. So fraction exponents, right? A base to an exponent with a fraction. I have to convert that into a radical form. All right, one more example. Let's take a look at this one here. 4 times the log base 3 of u minus 20 times log base 3 of v. Do I have the same base? Yeah. So the first thing I'm going to do, I'm not going to do the division part first because I have these multipliers here. So I'm going to take the multipliers and make them the exponents of my arguments. So I'll end up with log base 3 of u to the 4th minus log base 3 of v to the 20th power. Now, since I don't have any multipliers in front, I can take my arguments. Since it's subtraction, I'm going to make it a division. So I end up with log base 3 of u to the 4th is in the numerator, and v to the 20th is in the denominator. And that is as far as I can take it.